My whole purpose of coming to this place is that, of course, my MTech scholar, Vivek Chand, can you please raise your hand? Who has been the motivational factor to invite me to GeoMandu. I could not say no. So why I'm introducing him to all of you is that I'm going to talk about what we are doing right now, and hope you'll realize that I need. Can you please just hold on? Hello. So the whole idea is that to learn from the future generations, the type of intricacies which the profession is imposing on all of us. So I have chosen this topic, net zero, and what are the initiatives which a geomechanical engineer or technologist can really address. I'm sure you are aware that the whole world is going through a trauma of climate change. And very recently, there was a COP29 which has been completed at Kazakhstan, Azerbaijan. And this agenda was from November, it got over on 24th of November, 2024. Anyway, so by the time they fix it up, there has been a big series of COPs which has been happening. Now, COPs stands for the Conference of, parliamentarians, you may say, or the prime ministers, you may say, or the powerful guys, you may say, and they are discussing about what should be happening in the days to come to the entire world and to the entire profession. Very recently, in the last year, it was COP28, which was happened in the Dubai. This discussion is also in line with the climate action, which everybody is talking about. And what, Albert, you are talking about is nothing but the climate change and the climate action. Now, if you go through the summary of the gist of this, it highlights the urgent need to just preserve our heritage, but make it a part of our everyday lives to ensure it survives in the face of changing climate. Climate change is the key word right now. Now, I wanted to show you this because you must have realized since 2019, and what Mujib was asking, what has changed since COVID? Mujib, I think you are getting the answer to your question. COVID came, after that recession came, and now everybody started talking about the climate change. I don't know where we are heading and where it is going to end. So this is the magnitude of the problem which we are going to face. Appears to be very geopolitical statement, but then as a technologist, as a geologist, geotechnologist, petroleum geophysicist, what we can do to solve this problem, to address the issues, is a major point. So what I'm going to do in another next 15 minutes is to take you around through why this type of a discussion should be done in the capital of Nepal, Kathmandu, where people would have come for, leisure trips. But then this is becoming very, very important, very pertinent, very issue is, the temperature rise is taking place everywhere. And then there is a question that what's going to happen to the glaciers. I'm sure some of you are really aware that IPCC and IUCN, they have declared 2024 as the year of glaciers. And this is the place, this is the country which is supposed to be the hub of the glaciers. We don't want these glaciers to disappear. Now, this is where actually, why it is so, because those of you who are interested in hydrogeology, hydrology, would agree with me that glaciers are the one who keep supplying the fresh water to the entire sustenance of the world. There's another interesting thought which has been, initiative has been taken by the Nepal, that is, they want to preserve their climate. And if you go through this document, which was given by your earlier Prime Minister, Mr. Dahal, that is, Nepal is at high risk due to climate change. And if Nepal is at the high risk, all of us are going to not survive. The changed climate has altered the nature, amount and timing of the monsoon rains. It has increased temperature and changed rainfall patterns, and leading to more disasters and extreme events. I'm sure the basic theme of this conference, GeoMandu 2024, is also related to geohazards. I have seen a lot of papers which are going to be discussed on this. So the theme is set, and also I could find on the net that Nepal has a very ambitious plan to divulge into the cement manufacturing. Now, once you go into the cement manufacturing, there are about 124 registered cement companies, out of which 55 are operational. Each cement industry produces tons of carbon dioxide, and this carbon dioxide, being a greenhouse gas, is going to create a very catalytic role in climate change. So this is where the climate change is becoming very important. Some numbers that if we have to deal with this type of a situation, what should be the way forward? You can't stop civilization. You can't stop industrialization. Well, the answer is it has to be controlled in such a manner that it addresses to the net zero. And I'm going to discuss a bit about how net zero can help you or a country like Nepal in attaining its infrastructure development, economic development, and so on. So basic question is, what is net zero? The basic idea is, I'm sure many of us would have got through this, experience in our life. In the beginning of our careers, everything is zero, including the mark sheet, reads 0, 0, 0. Mathematics, physics, chemistry being such trivial subjects. The same is the situation today also. We truly do not know what net zero is. And I'm sure that politicians are using this word everywhere without realizing that who is going to take the initiative and how. So situation has not changed much. It is clueless. We are all clueless. But then the question is how to come out with some solution. So we have to redefine what is net zero. So this is where I have written the net zero made easy. And we are students, we used to study, net made easy. Solve 10 questions, you get the answer. So on the left-hand side matrix, I have shown the industrialization, civilization, chaos, which is getting created. And this chaos is emitting greenhouse gases. If I can take out this CO2, which is not a very easy task, which I am learning through my students, and in the form of either vegetation, gone are the days when vegetation could have helped you. The second is, you collect this and purge it inside the ground. And this is what actually is supposed to be the best way, and this is where the geotechnologists can play a very important role. So basically, removal of emissions from the atmosphere, and if this equation works out, well, everything becomes zero, less than zero. This is a win-win situation. Now this slide shows a lot of research frontiers to the budding scientists who are sitting over here. Incidentally, this activity would also address to the SDGs, which are proposed by the United Nations. Now the question is how to go ahead. Enough of preaching, enough of political debates, enough of political ideas. Now who is going to bell the cat? This is a major problem. So I have tried to give a very simplistic picture where many of you can participate and you can contribute to this basic cause, which is causing the main problem of, to the civilization. The geological carbon dioxide storage, also termed as sequestration, appears to be a good answer. And now I'm going to discuss most of it in my presentation over here with an intention that some of you might get excited, and then it will be my pleasure to work with you. The philosophy is that if I can collect all the carbon dioxide, use a pump, purge it inside the ground, the job is done. Very easily said, very difficult to attain. Remember, 1 ton of CO2, which is being emitted in the atmosphere, is approximately equal to the volume of a sphere, which is approximately 10 meters in diameter. So this is the amount of volume of the carbon dioxide which is getting emitted into the atmosphere. Now, if you read this statement which has come from IPCC in 2023, they have also acknowledged that if the geological storage site is appropriately selected, there was a time when many of us were working on atomic waste disposal for our countries, nuclear waste disposal. And for that also, the site characterization became very important. I remember Government of India spent crores of rupees, and I was a part of that, where we were trying to identify the candidate repositories where the nuclear waste can be dumped. The same is the situation right now. Why? We are not dealing with the radionuclides here anymore, but CO2 being a very corrosive gas is going to be a warning for all those who are trying to capture and put it inside the ground. So in this context, we will have to create a philosophy. What is the way forward? The basic philosophy is we have to identify the sources. Sources are primarily the industries, steel manufacturing, all sorts of refineries, cement manufacturing units, all sorts of pharmaceutical industries, and so on. Then what we have to do is we have to capture these flue gases. I'm sure the basic chemistry, what you have studied must be telling you that when you are capturing the gases which are coming out from the flue stacks, is there going to be a assorted combination of different gases. Now, how would you select carbon dioxide out of it itself is a big question, where people are struggling at this stage right now. Then what happens is, having captured this, I would like to compress it. Because subsequently you'll realize that when you are injecting the carbon dioxide, it cannot be injected into the gaseous phase. What you have to do is you have to convert it into a supercritical state. Now, supercritical state is a state of the gas which corresponds to a specific pressure and temperature. This becomes a dense fluid, which is what is going to be purged over there. Now, compression is going to create a big hazard itself because you require a lot of energy to compress the gas. Fine? So, the story is not very simple. It's not very straightforward. So, the first question is how I am going to audit the source from where the carbon dioxide is coming, how I am going to collect it, how I am going to fractionize it, and how I am going to liquefy it. Filtration, purification, cost and energy intensive process. But you have to identify a technology. So right now what I am trying to do is I am trying to study the different technologies which are available in the market, which are membrane based or glycol based or adsorption based, and how these technologies can be utilized to filter out the CO2. Truly speaking, this subject is the domain of chemical engineers, process engineers, and not for geotechnical engineers. But you have to learn it, because if you don't learn it, you can't move ahead. The next path comes to how you are going to transport it. Even after doing the compression, how are you going to transport it to the site? The site is supposed to be the disposal site, which might be very near to you, which might be quite far away from you. It could be in the offshore, it could be in the near field, offshore field, and so on. So what they do is, they propose to contain carbon dioxide in containers, or through the pipelines they have to transport it. Very risky proposition. Number one, you have to do a lot of metallurgy to understand what type of vessels, pipelines have to be made up of. Number one, CO2 is very corrosive. Who is going to take care of the reliability associated with this? Big challenge. Pipeline design we can do as a geotechnical engineer. But when pipeline is carrying carbon dioxide, how the leakage safety, corrosion associated with the pipelines and the vessels is going to be ascertained is a very big question. So this is where actually, again, our hands are very tight. Having transported this, I would like to utilize it. So far, people have been utilizing carbon dioxide as a feedstock. The carbonated drink bottles which you are consuming is a good example of how CO2 has been purged into the water to make a carbonated drink. But we don't require so much of carbonated drink in the world. And imagine the gigatons of CO2 which is being produced, which is already existing in the atmosphere. So this is an outdated thought. We are not going to live with this. What we are supposed to do is, this is what comes out to be again the purging inside the ground storage. And this storage gives excellent opportunity for geotechnical engineers to deal with a multi-phase system of the soils and the rocks. Very latest concept on which I wish that many younger people who are sitting over here should be working. I'm sure that this type of ideas are going to give a lot of development to the startups and a lot of commercialization of the thoughts And ultimately what we are going to do is we are trying to replenish the hydrocarbons into the subsurface. I have isolated this last step, which is a delight of geomechanical perspective and the geotechnical engineers. The whole process, if it can be done, this is going to be a boon. So in my research group, I have been working along with my students and several companies in India where we have tried a lot of options which are available over here. And I'm going to give you a very brief idea about how this has been done. So this is also a part of the SHARP project which I have been handling, which was sponsored by the Department of Science and Technology under ACT. ACT is Accelerating Carbon Technologies. It's a big consortia of about 21 countries and 10 oil-producing major companies of the world, mostly European. And this is where we are trying to understand, if I purge CO2 inside the ground, how the stress regime is going to change of the rocks, how the strains are going to change of the rocks when the purging is being done. Please visit the website to get more details about it. And we are proud to say that India is now joining the league of the people or the countries where sequestration is being talked about. So we are number 6 in the world right now where these type of initiatives have been taken. What are the initiatives which we have taken? Just to quickly mention them over here. There is a scenario 1, which is the carbon capture utilization. So what I was talking about is most of the industries, what do they do is they emit or they release a lot of toxic solid waste or liquid waste or the semi-solid waste. Can this be neutralized? Because handling itself is a very big question. Answer is yes, and this is what we demonstrated at one of the industries in India. The number 2 scenario is synthesis of hydrates, gas hydrates, where the carbon dioxide and methane can be captured into the sediments under pressure and temperature conditions, under cryogenic conditions, and then this is supposed to be the energy source for the future. The third scenario is geothermal energy extraction, which is a very hot topic under renewable energies, and everywhere it is being discussed, and India is participating very actively through all the oil companies in how to utilize carbon dioxide as the fluid where this can be utilized for heat exchange. Scenario 4 is what I have been talking about, is the sequestration, geological sequestration. So this is where my request is that those of you who are from different branches and engineering fields, geology, earthquake engineering, petroleum engineering, are most welcome to join this mission and let us work together. We have to take along with us the policymakers and the governments of different nations. Just to cite very quickly what has been done, this is a scenario 1 where the carbon dioxide has been injected into the slurry of the red mud, bauxite residues. Bauxite residues are at pH of 13.5, they are supposed to be hazardous. Now if I can neutralize this, this is going to be a win-win situation. So we did this work, and this is a beautiful example of how solid gases and liquids can interact with each other, multi-phase system. We continued our experiments at Hindalco, Belgavi, where we wanted to see how semi-solid material in the form of a matrix is going to allow carbon dioxide purging and adsorption. So with the large scale test to get the results. However, the big challenge is there is millions of tons of this material lying in the ponds and in the hillocks which have been created by human beings, waste disposal facilities. The question is how to neutralize this material, both in the ponds, lagoons, or in the hillocks which have been made by the human beings. Answer is yes, but this has to be done. The second scenario is gas hydrates. I do not know whether this topic enchants you or not, but truly speaking, this is a topic on which several countries are working because gas hydrates are supposed to be the future source of energy after the petroleum and hydrocarbons are exhausted. The big challenge is how are you going to simulate the hydrates into the laboratory setup? And fortunately, because of my students, we could synthesize these hydrates in the lab, what happens in the ocean bed, what I have tried to show you over here. And then we have tried to dissociate also these gas hydrates to see how loss of strength takes place. And this is where actually we are trying to work on methane replacement with CO2 also, with the hydrates. So ultimately the aim is to get the energy from the whole thing. Coming to the scenario number 3, this is the geothermal energy extraction from the abandoned oil and gas wells. India has several oil and gas wells which are becoming abandoned. The whole idea is if the heat which is from the mantle of the earth can be utilized in the form of the outcoming fluid when we purge water or some gas, this could be CO2, how much amount of heat can be exchanged. So this becomes a beautiful example of hydro, thermo, mechanical, chemical coupling. And this is where most of my students are working right now. We have published papers also. Those of you who are interested, please go through it and then contact either Vivek or my another PhD scholar is here, Yogendran, and he is very actively working on these type of thoughts. The last scenario which I wanted to talk about is the carbon capture utilization. So the situation is like this. Inside the earth there are faults, and if I do an injection well and if I purge carbon dioxide, the one thing I'm interested in how CO2 plume is going to migrate. And the second thing is the possibility is what are the mechanisms which are going to prevail this type of a situation. What type of storage mechanisms are going to work over here. Whether CO2 will leak through the faults or through the injection point itself is a major question. So I'm sure you must be realizing a lot of monitoring which is involved in this. The whole idea is how to deal with this situation where geomechanics becomes very important. So my closing slide is that what are the critical mechanisms and the controlling parameters which guide through the entire process here. It's a big matrix. And in one lifetime, I don't think that anybody can solve this problem. It has to be a group of people who are working in this area, which has to talk about the geomechanical attributes like porosity, permeability, stress, strain, Poisson's ratio, elastic modulus, chemical attributes, type of working fluids which you are going to use, their stability, rheology, how they are going to behave at temperature and pressure, what is the confining pressure, and when you are injecting something inside the ground, which is in a saturated state, what's going to happen to the effective stresses? The possibility is that the effective stresses might tend to zero, and that's going to cause the catastrophe. Thermal properties of the materials and the fluids which you are going to use, and the pressure and temperature controlled system. So this list is never ending. And I'm sure you keep on adding to this. Each of these topics, I'm sure, is going to give at least 10 PhDs and patents. So one has to take the challenge. So to conclude my discussion, I have to wish that we are going to avoid this type of situation in days to come. I hope the message is very clear. The selfie is being taken with the artificial greenery or the tree, and the entire thing has gone over. Now, if you want to come out of this situation, the net zero is going to be the panacea. Thank you very much for your time. I'll be very happy if you can send your contributions to me through email or through the questions. It will be a great learning. I'm not an expert in this subject. I'm just starting my learning from this, and credit goes to all my research scholars who have been working in this area. Thank you very much.